Hello, everyone. Thank you for coming. And welcome to the talk about eirinix, or how to write extensions for Eirini. The agenda for this presentation is to give you an introduction of a few of the concepts that you need to understand eirinix and why we've built it. Then we're going to describe a framework that we've built to help you write these extensions. And then Ettore will show you how you write one of these, and then we'll present some use cases so that it makes sense, so that it all ties up. And some of these use cases we've already implemented, which is great. Okay, so first, Kubernetes Webhooks. Kubernetes has a mechanism that allows you to intercept API calls. There are two types of interceptions that you can make. One is to mutate, and one is to validate. In our particular use case, we only use the mutating webhooks. The validating one is just giving you an opportunity as a developer to extend Kubernetes and add more validation to an API call. So for example, if someone wants to create a pod, Kubernetes calls you first, you get the definition of that pod, you can do extra validation, and then you give up a thumbs up or thumbs down, whether you like that pod or not. The mutating admission webhook is even more interesting. It actually allows you to change the definition of a Kubernetes resource. So Kubernetes calls you, you take the definition of the pod, and you go, okay, I want to tweak this pod a bit. I want to add a persistent volume to it. I want to add mounts, or I want to add a label. So this is very powerful, and these mutating admission webhooks are kind of like the bread and butter of what we do with eirinix. Okay, YAML. This is how you define a webhook with Kubernetes. You have to write one of these. You have to provide a CA bundle, the URL of the API server where you listen in for those Kubernetes calls. Namespace selector, that's very important. That's how you tell Kubernetes to only call you for resources that exist in a particular namespace. So in our case, we only want to interact or mutate the pods that are actually in the Eirini namespace. So that namespace selector helps us there. And then, of course, you have rules that identify which resources you want to mutate. So normally, you'd have to create one of these. You'd have to manage the definition. eirinix actually generates this for you and sets it up, starts a server to listen in for those Kubernetes calls. Okay, the next part is the other side of the issue. The Cloud Foundry app, that's actually a pod in Kubernetes. This is how it looks if you describe it. If you use kubectl describe for one of those application pods, this is what you get back. And the thing that we care about here is the source type. This is a special label that Eirini adds to all application pods. And this is the label that we look for when we decide if we want to mutate something or not. So using the mutating webhooks and using these special identifiers, the namespace of the app, and this special label, we can particularly identify which pods are actually created by Eirini, and then we can mutate them to do various cool things. Okay, so what is eirinix? It's just a framework. It's essentially a Go package, a Go module, filled with code that makes your life easier. It's boilerplate that sets up the HTTP server to do the HTTP server that listens in for Kubernetes requests. It generates certificates for you. It handles services for you, and just tries to make it as easy as possible for you to go in and write an extension. This is a piece that sits between CF push and the end state of the application on Kubernetes. So it's a great place to tinker with stuff, to try and add new features and make things better. And I just want to add that the reason we're doing this is to be able to help out with Eirini while not putting too much pressure on the Eirini team, right? So you don't want all features that Cloud Foundry has built over the years to fall on the shoulders of the Eirini team. So this is a great way to try and help, add new functionality, and extend what Eirini can do while being completely separate from the core team, let's say. Okay, and that's it for me, and now Ettore will take over.
Hello. So, as Vlad said, eirinix helps you to write components that sits between a user, which is doing a CF push, and the actual pod being started on the Eirini namespace. So what it's doing for you when you declare an extension, it's actually setting up a mutating webhook, and as you said, a server listening and actually understanding those Kubernetes requests, and actually building those objects that are hard to build other ways. So you need some helpers to get the real underlying structure of Kubernetes. So also, eirinix is not only using mutating webhooks, but it's also leveraging Kubernetes native watchers. And we will see a use case later on. So when a user does CF push, Eirini tries by requesting to Kubernetes to spawn up a new pod with your application. But Kubernetes, before doing that, will contact our extension in this case, or our set of extensions. This allows us to mutate the pod live before it's going to be actually in the namespace. Do not be scared. You don't have to read the code. I just put it here to show that with a few lines of code, what you get is mutating an Eirini app before it's going to be pushed. So in this case here, we are just injecting an environment variable to the pods that are going to be pushed. So whenever a user does CF push, this function gets hit, and here happens the real mutation. So as you can see, with few lines of code, you are able to actually have a mutation of an Eirini application. To note what this function is doing, it's returning an answer to the Kubernetes API as form as a patch set. So what we do, it's doing a difference between the two pods, the one which is actually the original pod, and the pod that we would like to have on our namespace. So we calculate the difference, and we send it back to Kubernetes, which is actually doing the mutating part. So to write an extension, it's actually easy, because we need mostly two files. Okay? One, it's encapsulating our logic of our extension. So whatever we want to do with the application pod goes here. And then what we need is just a main file to start our extension, and that's it. This is what we need. We need just, okay, we can bind to a service, we have a port, because of course this is still an HTTP server. So it's listening somewhere, and we just start everything. So let's go to the use cases that might shed a bit more light on how we use this framework and how it helps us to build pluggable component. That's the thing. We can swap component at this point very easily, and we can re-implement in other extensions. So it's easy to plug them in single binaries. So with eirinix, we played a bit, and yeah, we managed to have persistent support, logging, native Kubernetes logging, and SSH support, which is upcoming in SCF. We have not started yet with application security groups, but it's in the works. And yeah, Of course, it's just about fantasy here, because this is just a pattern that we identified that helps us a lot to build extensions. So it's up to you, basically. So let's see how we managed to have persistent support with Eirini. So there are two cases here. When you create a service, so we implemented a Persi broker. The Persi broker is simply creating persistent volume claims that are later on reused by the extension. So when the user creates a service, it's contacting the CC API, and we have our Persi broker, which is associating, as you request new services, new PVC. Those PVC can be reused by different applications as well, allowing also to share, actually, volumes between applications. So you can create as many services as you like, and you can say also, OK, I want 10 gigabytes of persistent volume claim. Give me whatever it is, the storage class. So this method is very nice because it gives you the possibility to actually have persistence for whatever storage class it's natively supported by Kubernetes. So you can have storage class like Ceph, GlueFS, whatever on the other side. But what you get at the end is the same interface. So you have volume mounted in your pod. And the component which is mounting the volume, it's the Eirini X Persi extension. So it sits between your CF push and the application which is actually going live. And it will mount the PVC that were created before with the CF create service. So basically, when we mount them, we are going to read in the pod definition the vcap services environment, which is actually having the credential to, not the credential, the ID of the PVC in this case, okay? So another use case, it's logging. So this is started also from a necessity because we were using Fluentd. Fluentd have some limitation. It needs a daemon set which is installed on each node of your cluster. Okay, and it is exposing by just mounting the local folder, the logs, and then it's going to be redirected to Doppler. So basically, what happens there, the node writes as normal logs, the container writes as normal logs in the folder, and with Fluentd, we just read that logs. Here, we changed the approach, and we are using more Kubernetes native API for doing this, okay? So in this case, the logaggregator bridge there, it's an Eirini X component, but instead of being actually a mutating webhooks, it's not sitting behind your CF push and your application being pushed in the namespace. What it's doing, it's actually implementing a Kubernetes watcher. So we get all the events on the Eirini namespace, and the logaggregator bridge will act upon them. So if we see a new pod, we will have another Go routine, which is actually calling the Kubernetes API natively. So here it is kubectl logs, but it is not actually calling kubectl. It is doing that by API internally. So on each new pod, it will start to track it unless at some point it will stop. When the application stops, we just retire the Go routine, and we are not looking at the logs anymore of the Eirini application. So basically, we are still very coupled to the Kubernetes API, instead of relying on some other mechanism that it's very connected and linked to the host which is running the application. So in this case, we just poke Kubernetes to give us all the information that we need.
One thing that I would like to add here is this kind of showcases how powerful this approach is, because we were able to implement this extension without writing or changing any code in the Eirini core source. And for something as important as logging, to be able to do that, I think it's very interesting. And this also exposes a solution that's much more native. You don't have to have a daemon set that mounts host files anymore. So it's a much better approach, and we were able to do it without doing a heart surgery on Eirini core. Yeah,
exactly. The good of this approach is exactly that as the Eirini team can continue releasing Eirini, we are completely separated on that point, and we still keep our logic well-defined. The SSH support. So basically, SSH support, it's a bit more complex, but still, if you can follow me, there are two steps on this, okay? We are pushing an application, and we are actually connecting to it, okay? So when we push, there is an eirinix extension, which is sitting there, and it's creating SSH keys and storing them as Kubernetes secrets. So this is happening, of course, before the application started. And when we generate the secret, we actually are mutating as well the pod to refer to those secrets as well. So the pod, from that point, have SSH keys, fingerprint that are used by the other components to actually connect to it, okay? Of course, the pod, in this case, it's having an SSHD daemon inside started as well. Otherwise, we couldn't connect to it, right? And what happens when actually we want to SSH with CF-CLI, right? So on the other side, there is a user which is just typing CF SSH as usual. It's going to contact a special version of SSHD Proxy. So we wrote a component which is reusing completely the Diego code, so it have completely compatibility with Diego. The only pieces that are added, actually, because it's just adding new pieces to it, it's a kube consumer that it's actually consuming the secrets that were generated by the extensions. So the SSHD proxy will create a tunnel with the SSH keys that were generated by the extension. Yeah, sure.
In this case, the proxy, is that going to be another container in the pod, or will one have something in mind?
No, it is part of SCF deployment. It would be part of it.
So where is that software come from?
It is our product for now. We built it separately for now.
It's in the Eirini Bosch release. Well, it will be.
It will be.
We just finished it like a week or two ago.
No.
It's just like the Diego SSH, the proxy. You just replace that with this. It's
Sorry, I guess so in a world where, so if I do a CF push of a Docker image, will I not get that because it's not my Docker image and I need to make sure I put that software in my Docker image?
Not the SSHD proxy. So the SSHD proxy, you have to figure out this as a part of the CF deployment that you have. So it's not part of the pod. So it's an internal component. But the SSHD daemon, it needs to be in the pod, okay? Otherwise,
So one of the things is if I do CF push, and it's probably the same now, I don't think daemon works if you do a push of a Docker image. So I just need to make sure that software is in there.
Yeah, I think so. I think you need at least something. If you push with a -o, right, a Docker image, you probably need something to be able to CF SSH. No?
The Docker app lifecycle brings the SSHD server along with it.
Okay.
So if we push Docker image.
Yeah.
Okay. We'll look at that. Okay.
the point is the original approach was about to go for a sidecar container on that. So your application doesn't need to have SSHD daemon, okay? But of course, for proof of concept, this is what we ended up to do, just to prove the point that we can actually connect to it by generating keys and making them consume on the application pod. Of course, that can be also sidecar. Nothing forbids that. And that's it. If you have suggestions, want to open issues, this is the eirinix repositories, and there are also the 3 repositories of the use cases that we just showed up today. And this is the blog post, which you can find on cloudfoundry.org. There is a summary on how to actually build an extension, start it, try it locally, and it gives also some insights on how you can actually mutate pods.
It takes you from writing the main.go to writing the extension all the way to the Helm chart that you could use to deploy such an extension on Kubernetes. And then we just created a Slack channel for Eirini extensions today, so you can meet us there. Thank you. Questions?
Can you also run it as a Cloud Foundry app, given it's just an HTTP server for Kubernetes?
I want to say yes. As long as the Kubernetes API server can reach it, I see no reason that you couldn't. Yeah.
Yeah.
You need some kind of queue down to register the webhook.
Yeah, yeah. But the extension does that for you. So as long as you deploy your app on Cloud Foundry and you have the right service account token to talk to the Kube API, it'll do it for you.
Yeah.
Cool idea.
It actually also, if you give also a kubeconfig, I mean, it has two ways to actually contact your cluster. One, it's inside the pod, and one, it's by standard kubeconfig file. So it can also be an external component, of course.
So can I think you might have set up with the SSH, but I can activate sidecars, that sort of thing, or can I create additional containers?
Yes, you can. That's the cool part. You can do sidecars for application or any application very easily.
So if I bring in the multi-build pack and the sidecar,
Mm-hmm.
then I can have the second half of that could be that the associated eirinix extension knows how to activate that to get into a running sidecar process. In lieu of your current, so they did the demo today, exactly.
Yeah.
And my follow-up question was, to you afterwards, was, can a build pack actually run sidecar? Currently, the answer is no, but they're looking at it. But this might be a way of build pack injects the software.
True.
with corresponding.
True, yes.
Yeah.
That could be.
Sounds similar. So what we do here for Persi is the extension receives the pod definition. It sees that there's a VCAP services that references a service that's a Persi service, and then actually adds to the volume mounts of the containers of that pod. So just like that, you can add more containers. You can do whatever you like.
Now, I need to ask the question I asked before because I still don't know the answer. With the Diego thing, so with the SSH, are you injecting new software in there?
No, right now, no. There's nothing injected. You
Okay.
expect SSHD to be available in the stack image, so we don't do that right now.
For
But
my generic sidecar conversation,
yeah,
could my extension inject the software? Is that a good idea? Is that bad? I mean, there's good idea, there's can I, and there's should I?
So-
Should I bring software to the build packs and then run it with an extension, or could my extension inject my sidecar?
adding more containers, init containers, I think that's totally fine. Each container has its own Docker image. It can have its own mounts, so you can do that with best practices in mind. What wouldn't be a good idea would be to somehow try to inject binaries into the running containers. Yeah, I don't even know how to do that, right? Yeah, so that might be a little bit weird. Yep.
Is the list of extensions, are they compiled at each time, or can they be selected at one time?
So if I understand the question correctly, when do they get compiled? They are deployed just like CAPI release is deployed. So you make the decision on what you want to deploy when you write your deployment manifest.
The point is, basically, it's up also to you. Because you can create a binary which is accepting flags, and by accepting flags, you can add or not, I don't know, to point. You can add the extension like this. So you can have more in the same binary, or you can runtime choose to have this or the other one. So you can, it's up to you to have a flag and enable or not certain extension if you'd like.
Right, you could do that too. You could have flags. You have full control. Yeah.
So for the logging example, for that bridge component,
It is horizontally scaled. So as many extensions as you like, the Kubernetes API server or the controller manager will notify you in parallel, I believe, yeah.
It sounds like you basically implemented some pretty core features of Eirini with EiriniX. Do you expect them to become part of the bigger Eirini project eventually, or do you think standalone extensions is the way like Eirini as a whole project will build up?
Long-term answer is yes, we expect all of these to make it into Eirini core, but we're taking it one step at a time. We now have a PR open for Eirini logging, which is something that's really wanted because you don't want to run fluentd that way. It's just hard and it's not nice at all. So this makes it easier. This will be the first thing that goes in, and then maybe after we all adopt it as a community, then EiriniX would go to Eirini core. And then other teams in the community start writing extensions that they support. For example, you wouldn't want the Eirini core team to support Persi and SSH and all of these. They can go to their respective teams, I guess.
Perhaps to really ask the question, regardless of who maintains it, is it worth them staying as fundamentally this extension style, even though they still might be maintained by a core team? Like, is there a good path even for your own core function?
We think that yes, they are worth keeping them. It's worth to keep them this way, and we were even discussing with Jules about you could have the OPI piece in the cloud controller create CRDs that are then consumed by something like EiriniX, and that becomes Eirini core. So this is, I guess, this is a native way to extend the Kubernetes, to extend Kubernetes. So if you do something like watch for a CRD that you can call a Cloud Foundry app, then you've just wrote an extension that does what Eirini does, right? So you don't have to talk to Eirini from the cloud controller. You just talk to the Kubernetes API all the time. So I think keeping them this way and separated is a good idea. Yeah. Hopefully that makes sense.
The activation, sorry if you said it earlier, I hadn't quite figured it out. The activation of these things, is it just on the creation of the pod? Can they be activated and turned on and off as a system? Can you triggering of these things? Where does that
No, it's a good question. These rules define when you get triggered. So you could trigger on just update if for some reason that's interesting to you.
What's the level of permission you need in a cluster to install and take permission webhook?
You need to be cluster admin to install it.
There's
Yeah.
no other type of user. Let's be honest. Step 2 of using Kubernetes, make yourself cluster admin.
Yeah. To install the webhook, I think you need cluster admin. Afterwards, you don't need cluster admin. There's some more interesting stuff happening in Kubernetes 1.15 where you can more granularly choose what you're being called for. And yeah, 1.15 has some features that we want to use in Quarks too for mutating webhooks. Right now, if you have a mutating webhook, if you see here, failure policy, fail. That line there means that if the extension is not online to mutate, your Kube API request will fail because that's the way you want it. You could write an extension that doesn't fail if the pod policy says so. But for example, you wouldn't, if you write an Eirini extension for network policies to do application security groups, you really want to fail if the extension is not there. So with this in mind, Kubernetes 115 allows you, if I recall correctly, to, I don't know how to explain it right now. If your server is in the same namespace that you're listening in, like the mutating web server, you kind of run into a chicken and egg problem. Because if your application, if your server goes away, there's no way for you to bring it back up because the Kubernetes API will try to ask you to start, but you're not there to start. So this type of problem goes away in 115. But yeah, cluster admin to create.